Okay, so what we're going over is how to find the domain and range given a graph. So the domain, we're looking left to right, and we discovered that the leftmost point is -2 and the right is 4. Now, we also talked about yesterday that we use brackets when it includes the point, and we use parentheses when it doesn't include. Okay, is this point here included? Is this x value included? Yes. So the domain of this one would start with a bracket. Does it include this point? No. So it's going to end with a parenthesis. If we wrote an inequality to represent the same thing, the inequality would be all the x values are in between -2 and +4. But it can equal -2, can't it? So it would be equal to there. Oops. And equal to. But we don't need one over here because it doesn't include the 4. You see how these two mean the same thing? Alright. So that's our interval for the domain. Now let's go look at the range. We're going to do the same thing. But for range, we're going to look bottom to top. Because that's how we will go from the least to the greatest y value. So go from the bottom of the function to the top. If it went down forever, the bottom would be -infinity. If it went up forever, the top would be +infinity. But this one doesn't do that. It goes from here, the bottom is at -3, to here. The top stops at +1. So this range for this particular graph goes from -3 to +1. Make sense? If we wrote that as an inequality, it would look like this. All good? Alright, let's take a look at that homework. I wrote the answers right above the column. Okay, quickly check 1 through 6 and ask if you have questions. Okay, do you see on number 3? The domain has less elements than the range? No, it is not a function. And the domain has less, not a function. Domain can have more. Domain can have the same amount. But if the domain has less than the range, it's not a function. Okay, the reason I wanted you to actually write them instead of underlining stuff is because I wanted to make sure you're not listing numbers more than once, and I wanted you to realize that. I wanted you to see that when the range only has one element, we only write one element. Okay? Could you take this and turn it into the set of ordered pairs? What are they? Good. Alright, any other questions about 1 through 6? Those are pretty easy, huh? Alright, so this is where the harder ones were, except for 7 and 10, because those were both not functions, were they? That's a circle, that's an x equals the absolute value of y. It's been shifted. Alright, let's go over number 11 and number 12, and then I'll quickly go back over number 8. So number 11, if we look left and right, do you see this has arrows at both ends? It goes forever left and forever right. So the domain goes from -infinity to +infinity. Now remember, with infinity, we use the parentheses because we can't include it. You can't to infinity. It's a concept. It's not a point. It's not a number. So Now this one, the range. The range of this one is just the y value of -3. And because it's not an interval, we're not going to use interval notation. It's just one value, -3. So we write that with a brace. Okay, so check that. Make sure you weren't using parentheses and brackets on that one, because it's only one value. Now on this one, it goes left to right forever. It goes up and down forever. So the domain is -infinity to +infinity, and the range is also. Now if we were taking a standardized test, instead of writing it this way, we might write all real numbers. I don't think you'll see the symbol for all reals, but the symbol for all reals is the double R. It's the R with an extra line on it. Okay, now yesterday in class we went over this one and I asked you to add arrows at the end. So if we look at this, do you see it's still going left forever? It's still going right forever. So what would the domain be? -infinity to +infinity. The range, bottom to top. It's going down forever, so the least value is -infinity. But it has a stopping point right here. What's the highest y value? 4. And that's how we got the domain and range yesterday. Alright. Now, the last couple. Number 13. I took it from this and wrote it as a table so I could see the differences really easily. This increases by 1, but this changes by -9, -7, -5, -3. Was that change constant? No. No, that is not. Okay. This one, we look at this. Up 2, up 2, up 2, up 2, as it changes by 1. So 2/1, 2/1, 2/1, 2/1, was it constant? Yes, this one is linear. When that change is constant, it's linear. Let's look at this. This is the x's increase by 4, increase by 4. The y's increase by 5, increase by 5, 5/4, 5/4. Is that the same rate of change? Yes. Now this one. What is the highest degree you can have on a linear function? For a line, the highest x value would have a power of 1. So is this one a linear function? No. But this one is. This one is just plain out and out y equals mx plus b form, isn't it? That's in slope-intercept form, so we can tell automatically that this is a line. What's the slope or the rate of change? 4. And what's your starting point when your y-intercept is -7? Good. Okay, your book work. Number 15 asks us to take this set of ordered pairs, that is our relation, and display it as a table, which I did, a vertical, a mapping, and as a graph. Should I connect the dots of the graph? No, we shouldn't, because it's just the discrete individual points. Now, that graph does have the form of what type of shape? A parabola. It's a parabola that's opening down. It's actually called a quadratic function. And if we wrote the equation of that function, it's f of x equals the opposite of x squared. Do all of these output values look like the opposite of the input value squared? Square this and take the opposite. Square this and take the opposite. Square this and take the opposite. Do you see how you get that? Okay. Now I'm not asking you to tell me that. I'm just letting you know that's what that is. Alright, 17. The domain. Do you see on this vertical line? First of all, is this a function? No. Okay. So vertical lines are not functions. This domain is just the number 3. Is every x value on that number line, on this line, 3? Yes. And then the range is an actual interval. So see, I wrote this within the braces to denote a set that just contains the number 3. This is the interval, and I showed that using the brackets. Any questions? Alright, on number 18, the domain and range were both the same. Are we good? Great. Alright, so here's another graph. And if you didn't understand it last night, let's talk about it again. Left to right, that's our domain. Least x value is -2, greatest is +2. It uses up everything in between them. So the domain is the interval from -2 to +2 inclusive, including those. The range is bottom to top. The lowest y value is 0. The greatest y value is 2. 0 to 2 inclusive. And yes, this is a function. It passes the Verdi test. 20 is not a function, though. Why is 20 not a function? Okay. Value of the input is paired with more than one value of the output. -2 is paired with both 4 and 0. And that is why it is not a function. So here's our domain, here's our range. Do you notice that the domain is smaller than the range? Not a function. Alright, this one. An electrician charges a base fee of $75. So to just drive out to your house, you have to pay $75, even if they don't do anything. And then they charge an additional $50 per hour. So if we let y represent the total cost and x represent the number of hours, you see that this function models that situation. And then we can set up the table. Is this relation a function? Yes, I called it a function, didn't I? It is a function. Alright, 22. This said let the x value represent the side length of a square. So if we had a square, x would represent the side of the square. And y represents the area of the square. And then it gives us the domain. So the domain is our x value. If a square had a side of 2, what would the area be? 4, 2 squared. Side of 4, 16. Side of 6, the area would be 36. Side of 9, the area would be 81. A side of 11, the area would be 121. Any questions? Okay. Graphs a little better. Okay. We'll do some more practice later on. Okay, and then the one that made you hungry. Hamburger, cheeseburger, Chick-fil-A, breaded chicken sandwich, and a taco salad. So what you should have done was label the fat grams on the horizontal axis, and then the fat calories on the vertical axis, and then plotted those points. Now, my graph is a little skewed. And the reason my graph is a little skewed, what is my counting number on this horizontal axis? 5. And what is the counting number on the vertical axis? 50. So if I did both axes to scale, wouldn't that vertical axis be stretched out a good bit more? So it almost looks like it's at a 45-degree angle right now, but if I had the same counting number on both the axes, which I don't have to have, but if I did, it would be much steeper, wouldn't it? Yes. Okay. Did y'all pick the same counting numbers I did?
Yeah.
Okay.
Well, no, I didn't.
You didn't?
I didn't choose in 20, so.
You didn't have to, did you? Alright. You didn't have to. We'll talk about soon, when we start doing graphs, good ways to pick out appropriate scales for our axis. We're going to do a unit on linear programming, and that's when choosing a correct scale can be crucial to the success. Okay. Today we're going to look at the rest of our PowerPoint from yesterday, because today we're going to learn how to evaluate functions. So tonight's homework will be on evaluating functions and understanding function notation. It will also be over a few more word topics. We're going to do a little bit every day. We're not getting away from that. nowhere. They do not bother us at all.
No, I didn't hear you.
Okay, who can read this correctly for me? Okay, Sabrina? Beautiful. F of x is equal to 3x minus 2. Okay? So what we're going to do today is evaluate this function. Who can read that? How would we say that? F of 3. F of 3. So what does that mean? F of 3 means find the value of the function when x is 3. When your input is 3. When the independent variable is 3. Plug in 3. That's what it means. It says plug in 3 into the function. So we're going to take and plug the 3 into our function machine. And when we do, it's plugged in for x. And we get 3 times 3 is 9, minus 2. And we get out 7. So this statement says the value of function f when x is 3 is 7. Or when we plug 3 into the function f, we get out 7. That's what this statement means. When I plugged in 3, I got out 7. All right, you try f of negative 2. So the negative 2 gets plugged in where the x was. So 3 times negative 2 is negative 6. And negative 6 minus 2 is negative 8. So the value of the function when x is negative 2, or f of negative 2, equals 8. Make sense? Okay. Alright, given this, it's not f. It's h, and it's not x, it's z. So we just name the function differently. Az equals z squared minus 4z plus 9. Find h of negative 3. Well, that negative 3 must be plugged in for every z. So we plug it in, and the first thing we'll do is square it. Minus 4 times negative 3 plus 9. Well, negative 3 squared is what? Positive 9. And then negative 4 times 3 is 12. And then 18 plus 12 is 30. So, h of negative 3 is 30. Pretty simple? Okay, so we're evaluating that function there. Alright. You guys know the sign language alphabet? A, B, C, D. Okay, work it and then hold up what you think it is. A, B, C, D.
That D? Awesome. Thanks.
Alright, everybody's right. equal to 3 times. Does that make more sense? Okay, good. So, g of x plus 2 would be 3x plus 6 minus 1. So, how many of you have a c up again?
I did.
You're just that good?
I told you okay. Ryan. He was like this.
There we go.
Got embarrassing like that. He's had an Australian seat.
Okay. Whoa.
Oh,
That looks confusing. But it's not, is it? Let's just take it piece by piece. Let's not be overwhelmed by it. Let's just take it piece by piece. Okay, so it looks like there's an f of 3 right here. You guys know how to do that?
No.
Yes, you do.
Yes. Yes.
How do you find f of 3?
Oh, you plug in three.
F of 3. F of 3 means to plug in 3, doesn't it? Okay, so what is the value of the function when x is 3? What is f of 3? 7. So f of 3 can be replaced with 7.
Wait, what?
Okay.
No, don't be embarrassing. It was really embarrassing. Yeah. Don't be embarrassing. Oh my God, yeah.
Okay, so when we look at this, f of x equals x plus 1. So if we find f of 3, we're plugging 3 into this function. So it becomes 2 times 3 plus 1. What is 6 plus 1? 7. Okay, now let's find f of 1. Plug it in. 2 times 1 plus 1 is 3. Well, now we know we can simplify this. This is negative 4 times f of 3, which is 7, minus f of 1, which is 3.
Oh, I get it now.
Negative 28 plus 12.
Or we can simplify, yes,
You can do that again.
and it gives us negative 16.
You got it right like that. What would you do? 12 minus subtract F3 minus F1.
Negative 16. Okay?
Yeah, I would just do it the other way.
You guys remember you said it the wrong way?
Yeah.
All right.
you said that.
Now, this one's interesting. Given f of x equals 2x plus 1, find x if f of x is 15. So what did they give me this time?
The answer.
They gave me the value of the function.
Wow.
So this time, and you just got to read. What did they give me? This time they gave me the value of the function. So I know the function, f of x, is 15. So I set 15 equal to,
Yes. Good boy. Thank you. Gracias.
okay? And we solve that and we get c. There we go. There's the happy face.
Okay, look.
Okay, this time instead of giving you a value for x, I gave you a value for the function. You had to take the function and set it equal to whatever the value of the function is. Okay, alright, I need everybody to be silent. Everybody be quiet. Let's go this slowly. This is another one just like it. If g of x equals 4x minus 7, this is asking us to find x, solve for the independent variable, when the function is 41. So, what you're going to do is substitute the 41 for the value of g of x. And then solve. So it looks like this. Instead of g of x, we substitute in what g of x equals 41. Does that make sense? And then we solve, and what do we get? Shout it out. 12. 12. Okay.
You would say g of 12 is equal to 4 and 7.
What you would say, what you could say at this point, since we just function notation and evaluating it given a graph and a situation. So you're going to have to really think carefully about, did they give me the independent variable? Are they looking for the dependent variable? So did they give me the x? Are they looking for the value of the function? So that is part of your homework. Okay, before we get to that though, I want to do a few more word problems. There they are. Here they come. Whoops. And there's the answers. I bet you know this one. Okay, this is out of your textbook, and we're going to do a couple of these problems in class so you have less homework. Alright, number 28 says, a car can travel 30 miles on a gallon of gas, and it has a 20-gallon gas tank. Let G be the number of gallons the car has in its tank. The function D equals 30G gives the distance D in miles that the car travels on G gallons of gas. Okay, so we get 30 miles to the gallon, and G represents the number of gallons we currently have in the tank. So D represents the distance we can travel given the number of gallons. A, what are reasonable values for the domain and range in this situation? Now let's think about it. We are pumping gas into the car. Is this going to be a discrete set of data, or will it be an interval? Is it something we can count? Do you count the gas as you put it in the car? Or does it measure how much gas you put in the car? It measures it. Okay, so the amount of gas that's in the car is going to be a continuous. So we need an interval. What are the reasonable values for the domain? So what does the domain represent in this case? The gas or the distance? Which one? The domain. The domain, I'm sorry. Not the D. The domain represents the amount of gas. The independent variable, the amount of gas. So how much gas could we have in our tank? The most gas the tank will hold is 20. That's our greatest value, isn't it? Can I put over 20? Nope, it'll start spilling onto the ground. What is the least amount of gas possible in a car? None. You don't want to have none, because then I laugh at you when I ride by. Not really. I would stop to help if I was busy. Alright. Range. In this case, because the domain represented the gas, the range is going to represent what? The distance we can travel. So, if we know gas, how far could we go? 0 miles. But if our tank was completely full, how far could we go? 600 miles. Does that make sense? Alright. Now this says how far can the car travel on 12 gallons of gas? Where would we plug the 12 in? G. And we do 12 times 30. 360. Okay.
What's the point of doing functions then?
Huh?
What's the point of doing functions? Like, you just did 12 times 30. What's the point of writing functions?
Because it can be anything in between. 12? Okay. What we did, if we wrote it in function notation, it would look like this. Right, because they gave you the equation here. I just wrote out to the side what it could look like. Okay. The next one. This table, we're going to go down to do the duck. This table shows the volume of water pumped into a pool after T hours. Determine the relationship between the time and the volume of water and write an equation. So, before we started pumping, at time 0, before we turned on the water, there was no water. An hour later, we had 1,250 gallons. And then 2 hours, this and this and this. Is it linear? 250.
Yes.
Okay, so how can we write an equation for this? So what's my independent variable? What's my dependent? Time. And the dependent is the volume, because the volume of water depends on how long I let it run, the time that I let it run. Okay, so V of t is equal to, my rate of change is my slope. So what did we decide this was? 1,250 for each hour. And then what was my starting point? 0. Do I need to write plus 0? No, not really. Okay, any questions? Alright, I'm going to let you go ahead and start your homework. It's those few problems out of that plus this. Now you really think about independent, dependent. What's my input? What's my output? Am I looking for a value for the input? Or am I looking at the graph for the value of the function, the output? Your homework is just 20, 22, and 23. Because we did the rest.